Our process involves the following equipment: a biogas storage tank to regulate the pressure before we burn it, and then the biogas burner. And there'll be multiple compressors, pumps, valves throughout the process, heat exchangers to capture the energy from the biogas combustion to be sent to later on our distillation column, and some separators. And also we will have a bioreactor, which is probably our largest piece of equipment, most elaborate. And then some centrifugal separators to separate the water, to extract that from the biomass, algae. And then a crusher to last the algae so the oil can be extracted. And then multiple separators, and then our transesterification reactor. And then after that is a distillation column to separate the methanol catalyst back out, and as well as some water. And then a settling tank to separate the glycerin from the biodiesel. And well, first off, we had to choose a type of algae or some characteristics of algae, so we'll know how large to size the photobioreactor. We chose a growth rate of about half a day and a lipid content of about 50% by weight. And from there, we decided that about a 10-acre photobioreactor would be a good size for the Moccasin Bend wastewater treatment plant. And with that in mind, we chose a tubular photobioreactor. And this is a series of clear tubes to where the algae water with algae and the nutrients can flow through, and while receiving sunlight and bubbling CO2 through for the nutrients needed. And we chose about a 1-foot diameter tubing over a 10-acre photobioreactor, which resulted in a volume of a little over 435,000 cubic feet, and the residence time resulted in about 1.12 days there. And the volumetric flow rate through that needed to have algae effluent within reasonable bounds was about 2,900,000 gallons per day, which is a fairly small fraction of what Moccasin Bend actually treats. And okay, well, after the photobioreactor, we extract the algae oil and it's sent onto the transesterification reactor. And some assumptions for that reactor is that the temperature needed would be about 120 degrees Celsius and a pressure of about 5.4 atmospheres, with a free fatty acid conversion rate of about 99%, and with the soybean oil in this case was 99% oil, or 99%. We're assuming that the algae will have similar characteristics and conversion rates here. And for the reactor sizing from those assumptions, we used a 10-hour residence time with a volumetric flow rate of 38 liters per hour. And this results in a volume for our plug flow reactor of about 380 liters, and which results in a length here of 69 feet. After that, the effluent from the reactor goes on to a distillation column where we extract the methanol back out to be recycled. And this column, we used a pressure of 1 atmosphere. I think it's going to be about 12 stages, and we used a reflux ratio of 10% and just the feed coming in on tray 5. After that, after the methanol is extracted, we mostly have glycerin biodiesel product that goes onto a settling tank. It separates naturally, and therefore we just allow it to slowly move through a plug flow settling tank type device to separate the two. And we calculated a volumetric flow rate through this tank of about 38 liters per hour, and the residence time will be about 2 hours. And the needed volume is going to be about 76 liters, and the volume tank that we decided to scale up to is about 200 liters. And which, some dimensions of the tank we decided would be good, about 2.5 feet tall, about half a foot wide and a length of about 5 feet. And that was it for our after that, biodiesel and glycerin are separated, and we have our two products. And that was it.
Jackie, you gonna call on somebody, Jackie?